Hi, this is Ms. French, and this is my presentation on density. You're going to want to have a piece of paper to take some notes on and to try some practice problems on. Also, don't forget to take the poll on my class website to get credit for doing your homework. And as always, feel free to watch the video as many times as you need to or to pause it if you're having trouble understanding a certain point. So what is density? By definition, density is mass per unit volume. An easier way to remember that or to think about it is that density is the amount of stuff or molecules in a given amount of space or volume. Okay, so if you remember a few days ago in class, I had a box and we talked about volume. Volume remains constant. Okay, the volume of an object doesn't really change. But if you put things in the box, then the density of the box will change. Okay, so if we had, for example, an empty shoebox and we filled it up with rocks, okay, small little stones, then the density will increase. I also like to think about lockers, like school lockers. They all have the same volume, but if you had an empty locker, it would have a very low density if it was just filled with air, as compared to a locker that has lots of books and coats and pens and pencils. Okay, there's more stuff in it, so it has a higher density. Okay, now to calculate density, you're going to have to do some math, and the formula for density is mass divided by volume. Okay, so that's really the only formula that you need to memorize. However, if you like using a little triangle method like we did for speed and then also for Newton's second law, you can use that for density as well. And then that would give you the formula for mass, which would be density times volume, as well as the formula for volume, which is mass divided by density. Okay, so whatever method works for you is fine. Just make sure that you try to be consistent, and I encourage students to try solving algebraically. That way they're only memorizing that one formula, density equals mass divided by volume. Okay, so if we look at the molecules of solids, liquids, and gases, it's very clear to see what has the highest density. In solids, molecules are all packed nice and neat into rows, and they're very, very close together, making solids like rocks, glass, wood, concrete, those things have the highest densities. Liquids, the molecules are still fairly close together, but they are a little bit more spread out, so they do have a lower density. And finally, in gases, the molecules are very spread out, making gases having the lowest of the densities. Okay, to calculate density, you do need to have two pieces of information, at least. You need to have the mass of the object or substance, as well as the volume. Okay, and in class, for solid objects, there's two different ways that you can find the volume of an object. If it's a regular shaped object, solid object, like a tissue box, then you would simply multiply the length times the width times the height. Okay, if it's an irregular shaped solid object, such as a rock or a crystal, then you would have to use the water displacement method to find the volume. And of course, liquids are a little bit easier. You simply pour the liquid into a graduated cylinder, and then you would record the volume in milliliters. Okay. Also, for solids, the unit that you would use is cubic centimeters. So let's try some practice problems. Okay, this first one, it says, what is the density of a block of wood that has a mass of 25 grams and a volume of 29.4 cubic centimeters? So you always want to start by writing down your formula and then going over what information has been given to you. You can make a DMV chart. Okay, in this case, I put a question mark next to density because that's what we will be solving for. And then you simply sub in the information into the formula. So you should write down density equals 25 divided by 29.4, which would give you an answer of 0.85 grams per cubic centimeter. And let me just take a second to talk about some of the common units used for density. For liquids, most often you're going to be writing grams per milliliter, and for solids, you're probably going to be using grams per cubic centimeter. Okay, understand that you could see kilograms per liter or maybe it might be grams per cubic millimeter. You have to look at what's in the problem that's been given to you and stick to those labels, to those units. Okay? So here's another one. A cup of metal beads has a mass of 325 grams. Using water displacement, the beads have a volume of 33 milliliters. Given the following densities, identify the metal. Okay, so the neat thing about density is that for a substance, it is the same, okay, no matter where it comes from. So, for example, all gold on the earth has a density of 19.3 grams per milliliter, and copper has a density of 8.86 grams per milliliter. Okay, and this is true even for different types of wood, glass, plastic, okay? And you're going to try doing this in class. Like there's a lab and there's some different objects like a fork or a spoon, and you have to determine the density and then tell me what type of metal the spoon or the fork is made out of. Okay, so to solve this problem, again, you would just sub in the information that's been given to you into the formula, and that would be 325 grams divided by 33 milliliters, which would give you an answer of 9.8 grams per milliliter. Okay, and looking at the information given to you, that density is closest to bronze, and therefore the metal beads must be bronze. Okay, try number 3 on your own. It says, I threw a plastic ball into the pool for my dog to fetch. The mass of the ball was 105 grams. What must the volume be to have a density of 0.6 grams per milliliter? Okay, so pause the video and think about the formula that you're going to use. Write down your math work, show your work, and then of course circle your final answer with the appropriate unit. Okay, when you're ready, hit play again. Okay, so again, our formula is density equals mass divided by volume. In this case, the mass given to us was 105 grams. When you sub in the information given to you, you should have written 0.6 equals 105 divided by volume. When you solve for volume algebraically, you should get the answer of 175 milliliters. Now let's try one more. What is the mass of a brick that has the height of 7 centimeters, a length of 12 centimeters, and a width of 8 centimeters, and a density of 0.8 grams per cubic centimeter? And my hint is that you're going to have to calculate the volume first. Okay, think about the formula, make sure you show your math work, and then of course circle your final answer with the appropriate unit. Pause the video, and when you're ready to see the answer, go ahead and hit play. Okay, so again, density equals mass divided by volume. In this case, to solve for volume, you'd multiply 7 times 12 times 8 for an answer of 672 cubic centimeters. When you sub the information into the formula and solve algebraically, you should find that the mass of the brick was 537.6 grams. Okay, so another reason that density is very important is that it will help you determine if an object will sink or float. By comparing densities, you can predict if an object will sink or float in a fluid. So if the object is more dense than the fluid in which it is immersed, it will sink. Okay, so this is why things like rocks and golds and most metals are going to sink in water. Their density is higher than water. An object that is less dense than the fluid in which it is immersed will float to the surface. Okay, so like a plastic bottle filled with air can float at the top of the water because the air in the plastic is less dense than the water. And finally, an object with a density equal to that of the fluid in which it is immersed will neither rise nor sink. Instead, it will float at a constant depth. So this is sort of how submarines work, and also why fish and sea turtles and dolphins, it's why they don't all sink to the bottom of the ocean, but they also all don't float at the top. Okay, so let's take a look at this next picture. Okay, on the left there's a bottle filled with air. Okay, its density is less than water, which is why it's floating. And the bottle on the right side of the screen filled with rocks is more dense, so it is sinking. And the bottle in the middle has a density equal to the water, and therefore it's what we say it's neutrally buoyant. It's not really sinking and it's not really floating because its density is equal. Okay, so try a couple more practice problems on your own. Again, you're going to pause the video when you're ready. You can hit play to see the answers. Okay, but just as a reminder, make sure you're showing your work and make sure that you label each of your answers with the appropriate units. Okay, and then here are the answers. Double check to make sure that your units are correct, and then also see if your predictions about whether the object would sink or float in water, okay, were correct. When you're ready, okay, there's a video, a Mythbusters video, for your enjoyment.
I promise to show you something really cool as long as you promise not to try it at home, okay? Okay. Now, everyone wants to know why my voice sounds higher when I inhale helium.
My simple fact is that helium is 6 times less dense than air, which means sound waves travel through it much faster, which makes my voice sound much higher. Now, the same effect can be achieved in reverse if I inhale something like
Sulfur hexafluoride, which is 6 times denser than air. I inhale some of that, and my voice gets really low, although somehow I'm still funny. It's scientific!
On that low note, it's time to start the test and flush out this potential viral flim-flam.
Now that we've got the gas, I want to replicate exactly what I can see in the video. We've got a fish tank and we got tons of tin foil. I'm going to try and make a boat that floats on the invisible line. All right. Give me the business end. I can't see anything.
We'll have to take the full tank on faith, just because we can't see anything. Now, Adam turns boat builder.
All right. Replicating the circumstances. You ready?
Yep. It's a simple proposition. The boat either floats or it sinks. But Jamie can't see why this won't work. And here's the proof of concept.
There you go.
So that's where our level is.
Right, somewhere right about there. Let's just be clear. This balloon is filled with air. And it drops. Unless it's in this fish tank. Where it floats. Because the fish tank's full of gas that's heavier than air. I just can't get a boat to float in it. As pretty as it does in the video.
All new Mythbusters, Wednesdays at 9 on Discovery.